Hello, Tom again. In this video, what we're going to do is we're going to look at different techniques or a technique to determine whether something is a specific type or if something is compatible with a specific type, primarily using the get type method as well as the is operator. So where I am right now, I'm in class program. I've just collapsed up main, part one and part two, and we're going to be working on part three. So in order to demonstrate the is operator, we're going to create another array list. I keep calling it a container, but it's more properly called a collection. So we should make that modification. All right. So like before, I'm going to just call it object list. Okay, it's kind of a generic thing. Now what we'll do that's a little bit different though is rather than add 3 simple points to the object list, I'm going to add a simple point, a Cartesian point, and then I'm going to add just a regular integer. Okay, so let's go ahead and do that. So we'll add a new simple point straight up, as well as a new Cartesian point. And finally, I'm just going to add an integer, 1, 2, 3, 4, just to be different. I'm boxing it implicitly here, but I could be more explicit by saying, object if I wanted to. So that would be explicitly boxing this integer as an object. But again, I don't need to do that, so I won't. All right. So I've got 3 things in my list. They're all objects because they either were objects to begin with or they got boxed into objects, but they're decidedly different things. So let's go through another loop, and we're going to go through each of the objects in the object list, and we'll display some information about them. Okay, so I'm just going to start off a little for each loop, and I'll add the brace in there to stop it from complaining. Okay. So in this loop, I'm going to create a string called message, and I'm going to start that string with what type the object actually is. Okay, so string message, I should probably do this out. Well, it's fine right here. String message equals new line, parameter is a, and then object dot get type. So get type is going to tell us what type of object it is. Because I'm concatenating it to a string here, I'm just going to explicitly convert it to a string using the toString method, and then concatenating a dot at the end. So that'll tell us what type it is in the output at least. So the next thing I want to do is I want to concatenate onto that message whether or not the object is compatible with the I-coordinate interface. Okay, so I'm going to use the is operator in this case. Okay, so if the object is I-coordinate. Now that kind of seems to me like I'm saying, is object actually, an I-coordinate, but it's not exactly what it means. What it means is it something that's compatible with I-coordinate? In the context of an interface, it means is this object a class or a structure that actually supports the I-coordinate interface? So the answer to this question is, whether or not the object supports that particular interface. So if that's true, that's what I'm going to append onto the message. Okay, so object, it supports the I-coordinate interface. I'll close that off, and let's add an else as well. All right. So next up is we want to see if it's a Cartesian point or not. Of course, in my output, I'm going to say if it is a Cartesian point, it's going to say parameter is a whatever the namespace is dot Cartesian point. But I want to, if it's not a Cartesian point, I want to actually see if it's compatible with Cartesian point. So we'll start off with that if. Is it a Cartesian point or not? Okay. So this is the type of code I'm using to answer this question. Is the object.getType, which we've used before, not equal to, or in a different context it might be is equal to, and then we're going to use the type of, and then the data type that we're checking. Okay, so what this, to me it's the opposite, or it sort of looks like it should do what is does, but it doesn't. It is checking the type, and it has to be exactly Cartesian point. okay, for this comparison. So if I say, I'm saying that the type is not equal to exactly Cartesian point. Okay, so if it is a Cartesian point, then this will be false. If it's anything other than Cartesian point, this will be true. Okay, so if it's true, now I want to do the same kind of thing I did before up here, except I want to do it with Cartesian point. So let's do that. So if the object is a Cartesian point, now again, that doesn't mean that it actually is a Cartesian point, but rather it is compatible with Cartesian point. What that means is if I had a class called enhanced Cartesian point or something that was a child class, this would actually be true in that instance. Okay. Okay. So it's either compatible with Cartesian point or it's not. And I'll close off that. And similar to what I just did for Cartesian point, I'm going to do the same thing, check to see if it's, as long as it's not a simple point, is it compatible with SimplePoint? Okay, so the code will look very similar. Let's try that out. Okay, so I just basically copy and pasted the whole thing and just changed it to SimplePoint here. So if the object type is not a simple point, not exactly a simple point, then I ask, is it compatible with a simple point? Now here's the thing though, with a class, this was kind of valid because there's a difference between being exactly a Cartesian point and then maybe being like an object that's somewhere related to it in using inheritance. With structures, I should say, in C#, there is no such thing as inheritance. So data structures do not support inheritance, which means that these two things are basically the opposite of each other. And I'm suggesting to you that it's never going to say it is a simple point struct, because first I say if it's not a simple point, the only thing that would cause this to be true is if it was a simple point and it can't get there. Because of the if above. Okay, now I'm going to leave this in my code the way it is for demonstration purposes, but I do have the note here that this I think is pretty much unreachable. All right, and then of course the else is it's not a simple point structure. Okay, so I've checked those three things. What I want to do is I'll just take out the extra blank line here. Display the message string that I've actually built. Okay, so let's save that and we'll try running it. Okay, so this time we're doing demo number 3. And we can see here the first thing in my object list was a simple point. You can see it supports I-coordinate, which is right, and it's not compatible with Cartesian point, meaning it's not a child class of Cartesian point. So that seems to be correct. The second item in my list was a Cartesian point. It also supports I-coordinate, but again, it's not a simple point struct in this particular case. And then the last thing was a int32, or just basically an integer, and it doesn't support any of this. It doesn't support I-coordinate. It's not a Cartesian point. It's not a simple point structure. So what we've done in this video is just demonstrated get type in combination with type of, as well as the is operator and how the is operator works in the context of different things. Okay, so all of those things will be handy and we'll build on those in later videos. In the next video, what we'll talk about is testing for equality. So we're going to actually go into the Cartesian point class and add things like an equality operator and a not equals operator. Thank you very much.